Hello, fellow space enthusiast. Have you ever wondered how we could enhance the way we explore and analyze data from space missions? Well, today's conversation is all about Python, the versatile programming language, and how it can be used in space exploration through Microsoft Azure. Let me take you on a journey through the cosmos of Python and Azure, revealing how these tools can empower us to unlock the universe's mysteries. Now, before diving into the technical aspects, it's essential to understand why Python is such a natural choice for space-related tasks. Adopted by a large community of scientists and engineers, Python's simplicity, readability, and extensive library of scientific tools make it an ideal candidate for processing complex astronomical datasets. When we fuse Python with Microsoft Azure, we unlock a powerful synergy that amplifies this impact. Diving right into it, the first step in our technical expedition is building an Azure virtual machine optimized for scientific computing using Python. To do this, one would navigate through the Azure portal, creating a new VM with Ubuntu as the operating system for its compatibility with Python. Select a VM with high CPU, GPU, and memory specifications to handle the intensive nature of data-related tasks. Once our Azure-powered high-performance VM is ready, the next phase is developing Python scripts focused on data management and analysis. For data storage, setting up the Azure Data Lake Gen 2 service is crucial. By connecting to this scalable service, large collections of datasets, like those from satellites, can be stored and managed. We write Python scripts to ingest, clean, and aggregate data from the data lake, where powerful libraries, such as Pandas and NumPy, come into play. We further customize our Python scripts utilizing machine learning libraries like scikit-learn and TensorFlow for predictive modeling, aiming to forecast atmospheric conditions or detect anomalies in space object trajectories. These models feed on historical data, which we process and curate using specialized tools like Iris and Astropy, making heavy use of Python's ecosystem. Azure functions, triggered via event-driven mechanisms, work in tandem with Python to automate the execution of batch jobs on the data lake. These timely jobs perform regular pipeline operations, preprocessing, analysis, visualization, to feed continuous insights to our data-driven explorations. Moving on to distributed computing, here the Python PySpark library steps in, allowing for massive data operations by harnessing the power of Apache Spark via the Azure Databricks service. We write Spark jobs as Python code, creating a scalable environment to manage and manipulate even larger than life-size astronomical data sets. Moreover, embracing the concept of serverless computing for peak throughput, we deploy Python functions to Azure, taking advantage of Azure functions to handle transient spikes in data processing demands without continuous provisioning of resources. Our technical armada also includes utilizing Azure's IoT Hub service to integrate ground station operations with our Python code. With the help of the IoT Hub SDK, Python becomes an intermediary to securely collect telemetry and operational data from instruments directly related to our space exploration projects. Crossing into domain-driven research, Python's ability to automate web scraping of scientific publications becomes part of our arsenal. Leveraging libraries like Beautiful Soup and Requests, Python enables us to parse and extract invaluable insights about celeste zero bodies and theories from online repositories. In the world of visualization, libraries like Matplotlib, Seaborn, and Plotly come to the aid, plotting the intricate details of star formations, galaxies, and more, helping not only analysts and scientists but also the public understand the wonders of the universe. Now that we've built an infrastructure that harnesses Python and Azure, it's critical to emphasize best practices in cybersecurity through Azure Active Directory and Azure Key Vault. As our Python scripts deal with highly sensitive data, securing access and encrypting information are non-negotiable aspects of our space exploration mission. To keep our system adaptive and future-proof, regular script updates using containerization technology like Docker and deploying our Python applications through Azure Container Instances provide portability and isolation across different environments for various tasks. Implementing monitoring and logging solutions, such as Azure Log Analytics and Application Insights, allow the tracking of our Python workflows. This is particularly important for debugging and ensuring that the entire system is running optimally, an essential component for any groundbreaking space mission. Our journey takes a final leap with Azure Kubernetes Service, deploying the necessary Python applications into highly efficient Kubernetes clusters to ensure scalability and resilience for automated data analysis pipeline workflows. We design deployment manifests, set up namespaces, and orchestrate applications for a seamless operational experience. As we wind down our technical excursion through Azure and Python, it's important not to overlook the community engagement aspect. By sharing Python code repositories on platforms such as GitHub or GitLab and participating in space-themed hackathons or AI challenges on Kaggle, the scientific Python community contributes to an ever-growing repository of knowledge for future generations of space exploration initiatives. In wrapping up this detailed guide, the synergy between Python and Microsoft Azure unfolds boundless potential for space exploration. By utilizing Azure and custom Python code, we can process, analyze, visualize, and secure vast amounts of space-related data. It paves the way for predictive modeling that furthers our understanding of the universe, drives innovation, and inspires countless minds to look skyward with wonder. We've traveled through a landscape where technology merges with cosmic dreams, where Python and Azure serve as the vessels carrying the beacon of discovery across the digital expanse. Remember, the potential of harnessing such powerful tools in the realm of space exploration is only limited by our imagination. For a universe of opportunities, visit neeraj.qzz.io and subscribe to TechLab to embark on further tech journeys with me. I hope this tech journey has been illuminating, and I invite you to continue exploring the cosmos of possibilities with Python, Azure, and technology. Join me for more conversations and discoveries. Visit neeraj.qzz.io and subscribe to TechLab.